Hi students, this is AJ sir. Let's study 9th standard ICSE Math exercise 6G. Mark the 10th sum and the 13th sum as IMP. Now in the third sum, two conditions are given. First of all, 7 times a 2-digit number is equal, and the number obtained by reversing is equal to the 4 times the number obtained by reversing the digits. Now, whenever they are talking about reversed digits, I prefer making a table. Now this time I am taking the original number as y and the units digit as x. So this is the original number and the reverse number is this. So as per the first condition, 7 times the original number is 4 times the reverse number. Open the brackets, like terms together, and you get this as the first equation. And according to the second condition, the difference between the digits is 3. So I'm taking x minus y is equal to 3. Now solving both of them simultaneously, we get the values of x and y, and the number is 36. Make sure you show all the steps of opening the brackets here and show the simultaneous equation, elimination, solving. Don't do any shortcut. Now in the fourth sum, two conditions are given. From Delhi station, if you buy 2 tickets for station A and 3 tickets for station B, the total cost is rupees 77. But if the number of tickets are 3 and 5 respectively, then the total cost is 124. What are the fares to A and to B respectively? So whatever is asked will be assumed as x and y. So that's the opening statement, the assumption of x and y. Then as per the two equations, get the as per the two conditions, get the two equations. Solve them simultaneously, get the answers, and don't forget to write the final statement as well. That is, the fare from Delhi to station A is rupees 13 and to station B is rupees 17. Now in the seventh sum, class 11 students wanted to give a farewell party to the outgoing students of class 12. How sweet of them. So they purchased 2 kinds of sweets. Let's say that the first kind they purchased of x kg and the second kind was y kg. That's what we have to find out. The x kg one was at the rate of 250 and the y kg one was at the rate of 350 per kg, and the total budget was 11,800. So first of all, we assume what is asked, x and y. Don't forget the units. Total mass of sweets purchased was 40 kg. So x plus y is 40. Now at the rate of 250, the total cost will be 250 into x for the first kind. And at the rate of 350, the total cost will be 350 into y for the second kind of sweet. So the total expenditure they will have to incur for all the sweets is this addition, but that comes out to be 11,800 as per their budget. Let's simplify this equation further, dividing by 50. So this is the second equation. Solve the two equations simultaneously and get the values of x and y, and write the final statement, and don't forget the units in the final statement. In the 8th sum, they have already assumed the weights of Mr. and Mrs. Ahuja respectively as x and y. Now both of them did a dieting course. Mr. Ahuja lost 5 kg and Mrs. Ahuja lost 4 kg. So with this information, let us first make a table. So this is the original weight, x and y, and the new weight is x minus 5 and y minus 4 respectively. Obviously they are in kg. Now as per the first condition, Mr. Ahuja's new weight is equal to Mrs. Ahuja's original weight. So that is equation number 1. And according to the second condition, Mrs. Ahuja's new weight is 7/8 of her original weight of her husband. So this is the second equation. Just cross multiply it and get it in the standard form. This is the second equation. So you got two equations and solve them simultaneously, show all the steps, get the final answer and write the final statement that Mr. Ahuja's original weight is 72 kg and Mrs. Ahuja's original weight is 67 kg. Now the 10th sum, which is IMP, a taxi charges in a city consists of a fixed charge. So irrespective of how much distance you travel, the fixed charge has to be paid if the meter is turned on. And of course there is a charge for the distance covered as well. Per kilometer there is a variable charge. Now for a distance of 10 kilometers, the total amount paid is this. This has the fixed as well as the variable component. And for a journey of 15 kilometers, the total charge paid is 465. Let us first find the fixed charge and the charge per kilometer first, which we assume as X and Y respectively, rupees. For 10 kilometers, he will have to pay the fixed price plus 10 multiplied by the per kilometer charge, and the total amount is 315 as per the question. Similarly, according to the second condition, for a 15 kilometer journey, he has to pay the fixed charge, that is X, plus for 15 kilometers, he has to pay Y into 15, where Y is the charge per kilometer. So the total amount he has to pay is 465. So solve these two equations simultaneously and get the value of X and Y. Next, they have asked how much will he have to pay to travel a distance of 32 kilometers. Here we'll use the values of X and Y. First of all, for 32 kilometers, the total price one has to pay is the fixed price, of course, plus 32 kilometers into the rate per kilometer. Substitute the values of X and Y and get the total answer as rupees 975. Now the 13th sum is very important. It takes 12 hours to fill a swimming pool using two pipes. Let's call them A and B. So when you use them together, it takes 12 hours to fill a swimming pool. So obviously if you use them separately, each will take more than 12 hours to fill the same swimming pool. And how many hours would each of them take independently? That's the question. So we will assume that pipe A takes X hours to fill the swimming pool and pipe B takes Y hours. Another condition given is that if the pipe of the larger diameter, let's call that pipe A, is used for 4 hours and the pipe of the smaller diameter, let's call it B, is used for 9 hours, then only half of the pool is filled. So using these two equations, first of all we'll need to create two equations using these two conditions, and I will use the tabular method, so it is easy to frame the equations without writing lengthy statements. So first of all, we are assuming that pipe A can do the work, which is filling the entire pool in X hours. That means in 1 hour it can do 1 upon X work, and it also means in 4 hours it can do 4 upon X work. Why 4 hours? Because that is one of the conditions given. So if I do into 4 here, I'll have to do into 4 here as well. That's how I got this. Similarly for pipe B, let's assume that it can do the entire work of filling the pool alone on its own in Y hours. That means in 1 hour it can do 1 upon Y work, and that also means that in 9 hours it would have done 9 upon Y work, that is into 9 and into 9, because that's the condition given in the question. Now what if A plus B were working together? If both the pipes are turned on at the same time, then the total work done by them in 1 hour is 1 upon X plus 1 upon Y. Remember, we can add the work only if it is for 1 hour. But in the question it is mentioned that both the pipes together can do one work, that is fill the entire pool together in 12 hours. That is, in 1 hour they can do 1/12 the work. So according to our assumption, in 1 hour together they can do this much work, and according to the given data, in 1 hour they can do this much work. That means this is equal to this. So that is equation number 1. And according to the second condition given, the work done by A in 4 hours and the work done by B in 9 hours together is half the work done, because they can fill half the swimming pool. So that is your equation number 2. So now let's eliminate x out here. I would like this to become 4 upon x. So I'll multiply this whole equation by 4 so that I get this equation. Now when I multiply this by 4 as well, here 4 and 12 get cancelled. So I got this as the equation. So I got 2 equations where the x terms are same, so I can subtract it. So this gets cancelled. 9 minus 4 is 5 upon y. Denominator is same, good. But here when you subtract these two fractions, the denominators are not same. So let me just write it down here. I can't do it mentally. I'll have to do LCM. So into 3 into 3 into 2 into 2. So denominator is now common, 6, and 3 minus 2 is 1. Cross multiply, you get y is 30. Substitute this value in any equation. Let's substitute in equation number 1 out here. We can substitute it so that we can now solve and get the value of x. Again, we'll have to remove LCM here. LCM is 60, so into 5 into 5 into 2 into 2. Cross multiply and get the value of x, and always write the final statement as well. Pipe A can fill the pool alone in 20 hours and pipe B could have done the same work in 30 hours.